A MacBook Pro. It's a 16 inches and it's coming in for no power. So as you see, one of the way you can easily identify between a 15 inches and a 16 inches is the touch bar strip being separated from the escape key, which is part of the keyboard, and then also you have your power button as well as your touch ID being physically separated from the touch bar strip. On the 15 inches, there's going to be almost the same thing, but then there's a small line between to differentiate, but the escape key will be directly on the touch bar. So this is a no power, and I'm hoping because the 16 inches they commonly have a failed they have a failure on the SSD line, which will be from. So let's show you guys. Let's go to our board view. So it's going to be a 20-01-20-01700. Now, oftentimes you get U9080 failing, and then when it fails, U9080 is supposed to output 2.5 volt to the SSD, but then when it fails, this is the U98 is a buck converter. So what it does is it basically takes a high voltage and then it outputs a low voltage. So when it fails, instead of having to output a low voltage, it outputs the same amount of voltage that it takes in, which is a high voltage, and sends it out as the same as a high voltage. And then when that happens, it basically damages one or more of the CD that the NAND chip. So when that happens, if even if you have only one faulty NAND chip, it means you have to replace the entire slots because the NAND chip are configured to function as one in unison. So we are hoping that it's a very common issue with the A1990, with the A2141s, as well as A1990, but we're not dealing with A1990 now. So we are hoping that that's not what the case is. So let's begin. So and again, when we deal with no power issues, we do not power the device using a charger until we can confirm what state the device is in before we can connect power to it. Okay, so let's quickly take the back cover out. If this is the first time you're doing this, you want to take note of the screw sizes and locations of the screws. They are not all the same. So generally the ones here, you see they are smaller in terms of size. So the four here will be of the same thing, while this two here will be the ones at the back. So you only have six screws on this one. Okay, my fingers now it's okay. So you have to use a tool to basically lift the cover. Be very sure that you do not stick the tool all the way because you don't want to damage it. Just a little bit, yeah. And then you can also use a suction cup to lift it. So whatever works for you. So my fingers are. I usually use my fingers to do the lifting. Okay, so also this has been assessed. It's been pre-assessed. As you know, most of the jobs that we get are from repair companies. So we rarely get working clients. Okay, so this was the region that I was talking about. And another thing I also wanted to mention also, so even with the A1990, when you're working on the A1990, first thing I know you want to do is you want to check to see if you have a short on your PB bus. Now, when you do get a short on the PB bus, even before you go to the other side of the chip, look at U9080 here. Right on this corner, see if it has a burnt mark. If it does, it means that U9080 got fried, and then it most likely 100% of 9 out of 10 of the time has already burnt out one or two SSD. So even before you because that information is it's important in case, for example, where you need to give your client like something concrete. Is okay. This is so if you find a short here and here you see that is your your U9080 is still clean, is the U9080. Yeah, if you find that U9080, so by clean aids, you see on just on the side here, because that section there, that's where your PP bus voltage. I'm talking about the A1990 now. Yeah, but even on the also even on your A2141, which is this particular one here, you just want to look around your U9080 just to be sure that it's not physically burnt, because if that is the case, then most likely you have an issue with your with the nans. Okay, that's it. So with the A9 with the U with the A2141, so there are three measurements I do once I disconnect the battery. The first measurement is to see that I have a short on my PPOS, correct, which I can check using either of those fuses. Obviously, I have my battery disconnected, and this is confirmed not a Chinese battery. So this is definitely an Apple original battery. So I'm not fearful that disconnecting the cable is not going to disconnect power from the battery onto the board. So that is that. So the first thing I'm going to do is I'm going to check to see if I have a short on my PP bus using this fuse. Now the reason why I use the fuse is because the fuses are sitting on the PP bus line. You understand? So I'm going to check that. Now after I confirm that I didn't have a short, the next thing I want to do is I want to see if I have a short on my right hand side, which is the 2.5 volt line. If I check that, then I want to go to the left. So I can use any of the components here, either a capacitor or an inductor. Then the next thing I want to do is I also want to check because there are two wings on the board. You have the right and then you have the left. You have the 2.5 volt 2.5 volt on the right, and then you have the 2.5 volt line on the left. Now for the left, I check these two capacitors here to see if I have a short. So if I have a short either here or here. So if you have a short on this side, most likely and then you obviously want to take the board out. But if you have a short on this side, sometimes the capacitors on the edge here might somehow kind of corrode, which would then cause the caps to fail. So just by removing one of these will sometimes solve the problem. If your problem happen to be that you have a short on the side, and then yeah, and it's coming from the capacitors. So those are the basic measurements that we do. So first thing we're going to do is we're going to have our multimeter in continuity mode, and we like to use the small multimeter because it's very loud. Now, when you are making a measurement using your continuity mode, the same measurement you use using a continuity mode, you can as well use your diode mode. Diode mode is more accurate. So if you happen to use continuity mode, be sure that you're not only concerned about the sound it makes, but also be concerned about the figures that you get. So first thing we are going to do is we are going to just confirm that so that beep tells you that A is equal to B. Both probes are equal. They are basically on the same line. So what you want to do now is want to have our black probe on ground. We can use SSD top as our ground, and then our red probe is going to be what we use for our measurements. So let's start from here. And then another thing is sometimes if you're not sure of a particular output that you're getting, you want to get a donor board, a board that you confirm that is working, to confirm that indeed you don't have a problem with that line. And as you can see, we don't have a short on that line. As we see that is still reading, that's good. The next thing we want to do is want to check our right, the 2.5 volt line, see if we have a short there. 07077, that's not bad. Now let's check on, that's not bad. Yeah, it's increasing. So let's check on the left now. Okay, that's about the same thing. Okay, that's fine. So we don't seem to have a short. And the next thing I'm going to do now is I'm not going to connect charger to the device and see what is it that I have on my PP bus line. So what I have on my PP bus line will determine where my troubleshooting will start from. So let's connect now. I can presume that it's safe to connect charger to the device. I'm just going to connect my charger, and then I see what I have. Now there are four ports. I can use either whichever ports that I want to use. I can use. So I have the charger connected. I don't get any fan spin. So let's see what is it that we have on our PP bus. PP bus should be 12.6. If we have 20 volt, if 20 volt circuitry is doing its job, it will get 12.6. But if we have 12.30, which is 12.3, then that will mean that PP bus is sitting at 5 volt. So let's have a black probe on ground, and then our red probe. Let's see, we have the charger connected now, so we want to see what we have on PP bus. 12.30. So 12.30, that is to tell us that we have 5 volt on our PPDC in, not 20 volt, correct? If we had 12.6, I'm just going to put it to 200 volt. So I'm going to show you guys again. So here we're getting 12.3. So if it was 12.6, it would mean that we have 20 volt. But because we're getting 12.3, it means that we have 5 volt. Now, so because we don't have any CD3215 here, for this one is a CD3217, not a 15. Because we don't have any CD3215 here, we are going to use this guys here. because here we can easily measure for our 5-volt line. So let's check this now. Let's see. Let's check again. 12.3, and it's not increasing. So what I want to do is I want to check so in our fuse. You see what we have? We have 5-volt and it's not boosting. And if we check the other port, same thing, we have 5-volt and it's not boosting. Okay, there's something that I want to mention now. So when you are troubleshooting your CD32s, whether it's a 32 CD3215 or CD3217, there are behaviors that you want to follow that will give you an idea what's happening. So if I plug my charger through the port, if I have the same behavior across the entire across the four CD32, 15 or 17, then 9 out of 10, my problem is not the CDs themselves. Do you understand? Because the CDs will not fail in the same particular way and then behave in the same particular manner. Correct? So if the four CDs behave exactly the same way, then most likely the problem is not from the CDs. Then you have to go look past the CD32s. Now, if I plug my charger to one port and one and inside out of the, because in your machines you will either have 4 ports or 2 ports, correct? Except the 12 inches where you have 1 port. Now, if I out of the 4 ports, this is important. If three fluctuates, they go 5 and then they go 0 and then 5. If three of those do that and only one stays at 5-volt, the problem where you want to start your troubleshooting is the one that is staying on 5-volt is the one that is not trying to boost at all. That's where you want to start your troubleshooting from, not the ones that are going 5 and then drop to 0. Because you would think, okay, the ones that are going 5 and drop to 0 are the ones that are fluctuating. Those are actually trying to boost. So if you have three and then you have across the, if you have four, and across the four, you have one that is stable on 5-volt, but you have three that is fluctuating. Now, those three are the ones that are okay, and the one that is just stable on 5-volt, that is the one that you want to concern yourself with. If it happens on a 2-port, you have one that is stable, and then the other one, the same thing. That is the one that you also want to concern yourself with. So we are gonna check now to see, and then also because of time, now we know that we have issues with our CD32, which is not CD32. We have an issue with our PPTC in because we are yet to establish if the problem is going to come from the actual CD32s themselves or something else. And see here, the battery here is somebody somehow, I don't know what they did here. One of the battery cell. I don't know what they tried to do there, but that's not good. I don't know. Did they try to remove the batteries or something? I don't know. Okay, so now that we know that we definitely need to work, we are going to start our work from the PPDC in voltage. Let's quickly take the board out. Again, if this is the first time you're doing this, you want to understand that the screws that I'm taking out, though I'm using a T5 screwdriver, they are not all of the same length. So if this is the first time you're doing this, you want to take note of your screws. So the T5 are out. Let's now grab a T4. Your multimeter will generally be your guide to tell you what to do and the next step to take. So let's quickly take, you see what I'm saying, the cowlings. So, I mean, if this was a 2016, 2017, the cowling will be there. And obviously, and that is basic. That's also the same thing with the 15 inches, hey? So the 15 inches as well, the cowlings will stay on the 2016, 2017, but 2018 and 2019, the cowlings will not be there. So it's the same thing with the 13 inches and same with the 15 inches. fine, don't worry. Now we can disconnect the cables. Let's erase those. You're not, the camera is not too far away now. Okay, all screws are out and the cables are disconnected. Now the board needs to go out. While you're doing this, be very sure you don't have any type of resistance taking the board out. If there is any, make sure you manually remove the obstruction from the way and do not break the cables. Okay, so now we are going to inspect the board. We are going to concern ourselves with the CD3217 because we have an issue with our PPDC in. It looks like there was some kind of liquid incident around here. Hmm. Most likely somebody also kind of cleaned the, yeah, yeah, there was a bit of a, there's some kind of liquid incident here. Let's try to clean it a bit. Idea. Okay, so I'm not sure if there was any, I'm not sure if there was any component here, this here, and here. So let's get another board. Okay, so so that is missing, I think. No, I don't think so. So there is definitely nothing there, but there is something there. Let's see. So okay, so that, it's that, and yeah, there is nothing there. That's fine. It's not populated, and there is nothing here as well. That's not populated. Okay, but yeah, there was definitely liquid around this section here. And this guy here, what's okay, there was also nothing there. That's fine. And here and okay, so what we want to do, this let's see, what is that and what is that? Okay, before this, there's definitely a concern here. But first, let's see what's the behavior. What behavior do we get across the CD3217s? Okay, start with this guy here. What do we get? Now we have 20 volt. Interesting. What's happening? Um, don't tell me that cleaning did anything. That's yeah, and it's 12.6 now, and also we're getting 20 volt. No, it's stable. Okay, let's check the other port. 20 volt, obviously 12.6. Okay, so and then let's check the other channel. So we flip it. 20 volt, and then this channel here, 20 volt. Oh, interesting. Okay. Um, I don't know if to say that the cleaning that we did wouldn't have. Okay, let's see. Let's do that. Yeah, we can easily measure from PP bus. Let's see what we have on PP bus. 12.6 means we also have 20 volt on that side. Okay, and then this side 12.3, 12.6. Okay, okay. This our machine seems to be working. So we didn't really do anything that I could point to other than the cleaning that we did. Okay, so let's see. Let me have a look at that before. Okay, but that was such a mild cleaning. I mean, it wasn't. Okay, let's see if we now have a working board. Backlight. No. So backlight only comes in when after the machine starts fully, but there is image, but there is no light on the screen. Only then there is backlight. So backlight does not have a role in device not turning on. It doesn't have a direct role. Sometimes you may get one of those uh, machines that a sub rail might be a problem and translates into something else, especially the M series. For example, if you have a short on your 5-volt line, which is going to be on the screen, which is going to go to the backlight driver. But it's very rare to have a machine that has a problem with backlight not to start. Okay, so let's have the screen connected. Just minimal cables to get the device to test it. So let's have one speaker at least connected. None of the fans. Okay. You can connect your fan even while you have power on the machine. That's not a problem. So there's no potential harm. So the fan does one thing and one thing only, which is to spin. Okay. It's very interesting. It's very interesting. Okay. So we apparently have a working machine. So we are gonna do more testing to this, and yeah. But other than that, okay. Thank you guys. I'll see you guys in the next time.